See, I think I should be live now. If anyone's already here or you're just joining, let me know that you can hear and see me in the chat. That would be great. I always like to double check. And I know I'm a couple minutes early on the stream right now, but I'm gonna make sure everything is streaming fine on YouTube and LinkedIn. So if you're in any of those platforms, say hello in the chat. And if you want to, you can always put in where you're watching from. It's kind of fun to hear about as well. And while everyone's kind of joining in, I'm just going to make sure the links are in the right place here. Somebody said, all good, awesome. Thank you for letting me know. And you're watching from Toronto, awesome. I went there once a long time ago, but I didn't really get to explore too much. I was there for work, but I'd love to go back. One of my friends is actually over there right now as well. And I'm in Seattle, so I've gone to Vancouver, BC quite a bit for Canada. And yeah, hello everyone. I see people joining in. Again, I'm just getting situated here, making sure everything is streaming all right. But feel free to put in the chat where you're watching from. Maybe also put in why you're interested in computer vision and potentially monitoring computer vision models. If you have a project you want to talk about, put in the chat. I always love hearing about kind of what things people are working on. All right. Looks like people are joining in. And again, we'll get started here in just a minute. Just gonna wait a minute for people to join in and get a little situated here. I'll start sharing my screen, and then we'll go through this in a little bit. Someone said watching from Miami, and someone said India. I have not gone to India yet, but I'd love to go visit sometime. Someone said Tunisia. For the person in Miami, I used to live in Melbourne, Florida, before moving over to Seattle, which is like an hour south of Orlando. Kelsey said, hello from Seattle. Again, for everyone joining in, we're just going to wait a minute before we really get going, but feel free to say hello in the chat and where you're watching from. Again, if you want to share anything about what you're working on around computer vision or why you're interested in learning about monitoring computer vision models, throw it in the chat. It's always really fun to hear about kind of projects. Someone said the Middle East. Someone said San Francisco. Pleasanton, California. I always forget exactly where Pleasanton is. I think I've been there, but I know I confuse it with another city as well. Somebody said they miss Miami. I think that was a person who lives in Toronto now. Someone said, hello from Seattle. Always fun to see other Seattle people in here. And again, we're waiting just a minute. Someone said it's near San Francisco. Yeah, I'm pretty sure I've gone there when I've gone for a Bay Area trip before. Again, for anyone just joining, we're gonna get started in just a minute here. I'm just waiting for a few more people to trickle in. And again, say hello in the chat where you're watching from. Maybe also why you're interested in computer vision and monitoring computer vision models. And I'm gonna share just a couple links before we really get going here. One, so we're just gonna have a little bit of slides today, but a lot of this is actually gonna be us running through code in a Colab notebook. So anyone who wants to follow along, which I hope a lot of people do, all you're gonna need to do is one, just have a free WhyLabs account, which there's no card or anything required to sign up, so it should be very easy. And then a Google account, because you'll want to run the code in Google's platform. So I'm assuming most people here already have a Google account. I'm going to share this link in the chat if you want to sign up for the free WhyLabs account already. I'll bring it up again when we get to kind of the setup phase. And then we're going to run, we're going to use WhyLogs, which is an open source library. I'm going to share the link in the chat as well. Also, all these links, if you're watching on YouTube, are in the description down below. And then I'm just going to share them in the chat here, and I'll share them on the LinkedIn chat too, so anyone watching the stream there can follow along as well. And then here's the link to the Colab notebook. Again, I'll bring this up again if you don't open it right now, but if you want to go ahead and open this up, you're more than welcome to. But really the only thing for setup, and again, we'll cover this later, is you'll probably just need to create that free WhyLabs account. Again, there's no card or anything required. It's very easy to create. Just put in your email. I think you might have to verify your email, and then you're good to go. And I'm going to share these in LinkedIn, and then we'll start going through these slides. So again, if anyone wants to say hello in the chat, a lot of people already have, which is awesome. And I love seeing where people are watching from. That's really neat. And if you want to put in more details around why you're interested in computer vision and monitoring computer vision models, put them in there. Usually people have some sort of project. Oops, I don't know if my links went over on LinkedIn. Let me try this again real quick. All right, cool. They're posting now. Also, how's everyone doing today? It's Wednesday, middle of the week. All right, so I've shared all of the links in the chat, and we're good to go. Start going through the slides. And like I mentioned, we're going to do some slides, talk about some concepts and intro to some things. And then we're going to go and do a much more of a hands-on part with a lot of code. So hopefully you're excited about running some code with me here today. If not, you can also just watch what I'm doing. But I definitely encourage everyone to follow along. And someone said they're watching from St. Petersburg. Yeah, I used to go there too. If you weren't here at the beginning, I used to live in Melbourne, Florida, so familiar with those places. St. Petersburg is very nice. All right, so let's get going. I've shared the links. This is computer vision and ML monitoring. We're going to build and monitor a computer vision model today. And hopefully you'll be able to take what you learned today and apply it to your own projects, whether that's like a hobby type project or something professionally. So what this workshop is, like I mentioned, we're going to go through some slides, cover some high-level concepts, and then we're actually going to go and implement ML monitoring, and we're going to actually train a computer vision model with TensorFlow on kind of our own data set. So if you've never trained a deep learning model or a computer vision model, I will be going fairly fast through that area, but if you've never done that before, this actually hopefully can be a good little start for you as well, because you'll see how you could bring your own data in and train a classification model with TensorFlow. So this is hopefully a very friendly introduction to building and monitoring computer vision models with TensorFlow and Keras. And then we're using WhyLabs and WhyLogs for monitoring, kind of designed for no previous experience expected, but definitely knowing some Python and machine learning concepts will be helpful. Because I will be walking through the code, but I might not be able to break everything down for you depending on your experience level. But just keep in mind, you can't learn everything in an hour, especially if you've never done something like computer vision before. So parts of this could feel fast-paced and challenging, and that's totally okay. Ask questions as we go. So if you're watching on YouTube or LinkedIn, there should be a chat on the side. Ask questions in there. I will see them. I will do my best to monitor them as we go through the workshop. If I don't get to something, it's probably not that I'm ignoring you, and you can follow up with me after the workshop as well. So quick introduction about me. I'm Sage Elliott. I'm a machine learning and MLOps evangelist at WhyLabs. We build tools to enable AI observability and ML monitoring anywhere in your pipeline. We have a lot of interesting tools around different types of data. So like today, we're going to be looking at computer vision data, images, but we also have open source tools for logging language metrics around large language models, for example. And for over a decade, I've worked in software or in hardware, usually with startups and some small consulting agencies, mostly around Seattle, but also, like I mentioned, Melbourne, Florida. I saw there's quite a few Floridians in the chat already today, so you might know where that is. And just in general, I love making things with technology, and I love trying to combine hardware with some technologies like computer vision, or I'm experimenting with a large language model thing, trying to put on like a Raspberry Pi robot or something like that. So again, I know some people already introduced themselves, which I thank you for, but I see, there's more people in the chat. So if you want to throw in the chat where you're watching from, why are you interested in ML monitoring, specifically around computer vision? I know some of you haven't said it yet, but I'm sure you have really cool side projects or professional projects that you're working on. And then also, link is in the description on YouTube, but you can join the Robust and Responsible AI Slack and introduce yourself there. So if you want to stay connected after this workshop, that's going to be a good place to do it. That's also going to be a good place to ask questions, again, after the workshop. During the workshop, definitely ask them in the YouTube or LinkedIn chat. That's where I'm going to see them right now. I won't see anything in the Slack channel until after I am done streaming. So definitely introduce yourself there and stay connected with other professionals and me, and ask questions later. So again, just to recap on setup, you're going to want to have a Google account because we're going to be using something called Google Colab today. That's going to allow us to run code in our browser. And if you've never done a lot of programming before, or you haven't done something with like TensorFlow, don't worry, because you'll actually be able to just run all the code in the code cells and get the result that we're looking for. We're going to be training a computer vision model, and then we're going to be looking at how we could kind of monitor that model. Like we'll simulate it being in production for 7 days, and we'll see how we might want to monitor those metrics from a computer vision model. So again, the only thing you probably need to do if you want to follow along for the whole code portion is create that free WhyLabs account. Again, there's no card or anything required. Should be very easy to sign up. Otherwise, you have a Google account, and we'll be able to install everything we need to when we open up the Colab notebook, and it shouldn't take us very long to get set up. So we're going to use Colab, like I mentioned. We're going to use TensorFlow and the Keras API that's built into TensorFlow to train a computer vision model. And then we're going to use WhyLogs, which is an open source library we maintain at WhyLabs for collecting data profile metrics that we can use to monitor over time for things like data drift, et cetera. And we'll be using WhyLabs today to monitor that over time. So real quick, what is TensorFlow and Keras? And let me know in the chat, have you ever used TensorFlow or Keras before, or maybe even another deep learning framework like PyTorch? TensorFlow is a deep learning library. It's maintained and created by Google. It's very commonly used in computer vision applications, almost any kind of deep learning application. And today we're going to be using a kind of pre-built model for us that's very popular in computer vision called ResNet 50. So it contains the architecture for that. And we're going to use transfer learning, which means it was already trained on a whole bunch of different data, and we're going to give it new data and kind of fine tune it on our new data. And you'll see just in a few kind of epochs through our data, it's actually going to learn pretty good to understand what we're looking for. You can go to I think it's just tensorflow.org or tensorflow.com to find a whole bunch of other resources on it. One cool thing about TensorFlow is you can use it for web. So they actually have tensorflow.js. You can actually run models in the browser, which I always think is insane when I think about it. And then you can also use TensorFlow Lite to create lighter weight models and deploy them to things like Raspberry Pi. And they have a lot of kind of good tooling around production. So a lot of people always ask, TensorFlow or PyTorch. I actually really like them both. Sometimes I like writing code in PyTorch maybe a little bit better. But TensorFlow has a kind of more mature deployment ecosystem around it right now, but PyTorch is definitely catching up, and they're both really great. So I know someone was maybe thinking that question, and today we're using TensorFlow and Keras, but both of them are great deep learning frameworks. So what is ML monitoring? ML monitoring is the collection of statistics. That's usually like performance data and metrics from ideally every part of the ML pipeline that you think might break. But when you're just getting started, I always recommend just logging the model inputs, model outputs, and then when you can, some ground truth to see how performance is. And we'll take a look at what this looks like in a minute today when we actually get to the hands-on part. And AI observability delivers actions and insights based on what's going on, so you can take appropriate action. So like if something happens to the data in your pipeline and your model's not performing as expected, hopefully you can use that kind of data given to you to go troubleshoot your model and fix it. And again, we're going to see this hands-on today. But here's a little graph. Don't worry if you can't read all the words right now. It's just, you have a production environment where you're running your inference, potentially doing retraining, etc. You have a tool that's collecting some form of AI telemetry. Today, we're using WhyLabs for that. And then you want to have probably some sort of system to ingest those logs and, visualize them, set up monitors. So when something does go awry, you're not manually checking all the time. You'll catch it very quickly. And then you want to add at least alerts out of that, probably at the bare minimum, but you can also set up like workflow triggers. So if you have a really good MLOps pipeline, it's going to allow you to, catch data drift very, very quickly, collect that new data, retrain a model with that new data, and then deploy it in production. So ML monitoring is a common part of kind of the whole MLOps pipeline once you have a model in production. I always like to ask anyone watching, do you have models in production as well? Let me know in the chat. And if so, have you ever seen anything interesting happen with them? You don't have to go into too many details if you don't want to talk about it, but have you ever seen something happen like data drift occur where the data no longer matches up with the training data set and your model isn't performing as well? Again, let us know in the chat. It's kind of always fun to hear about what people have experienced with putting ML models in production. So why is it important? I've already mentioned kind of like data drift, and we'll talk more about this a little bit as we go. I won't go through every single one of these bullet points, but basically a lot of things happen when you put a model in production. Usually that is data changing in some way. So data drift occurs. That could be from seasonality. That could be from, having new users in the platform, something changed in the world where, your model or people interact with your model differently. And that's called data drift. And like I mentioned, a good way of thinking about it is just the data going into your model no longer really matches the distribution that it was trained on. Is kind of a good way to start thinking about it. And we have things like concept drift. We'll talk about this a little bit later too. And then obviously the performance data, like you've probably already used if you've done any ML before, like accuracy or recall. We have things like bias and fairness, explainability, and obviously your business KPIs. And bias and fairness is really interesting to me. When you have a model in production, how is it performing on a specific set of classes? We won't be going deep into this today, but I want to call it out as a really cool feature and something you'll probably want to have if you think that might be something your model could have, is like a bias on prediction. So like a common example of that is there was a big tech company a while ago that had a credit card, and when you looked at the data, they had high approvals for men and very low for women. That would be something you want to monitor in production. Make sure that your model isn't incredibly biased towards one of those classes. And we have a saying here: bad data happens to good models. So just keep that in mind. So a quick example is data quality changes. And this is something I've seen a lot of. I don't think I said it in my intro, but I have done a lot of work with computer vision, and data quality is a big issue here. So especially if you have it deployed on like an edge device with a camera or something like that, it's easy that an input sensor, in this case a camera, could be damaged or moved, causing bad data to start coming in. And then this is really funny. I always think, oh, you put this in like a manufacturing floor or somewhere in a building, you're in a controlled environment, you don't expect, a lot of seasonality changes or anything like that. But something always happens, like someone turns off a light or someone changes a mat in the background or something like that. And we'll see an example of this today, actually, in our data when we simulate our model in production. Data drift, I already kind of mentioned, talked about data drift, how that's just the input data kind of changing from the distribution of the training. So again, has anyone experienced data quality or data drift issues? Throw it in the chat. One thing I've seen a lot of is seasonality as well. So if you are putting a camera outdoors and you're detecting, let's say, an animal, and the data that you trained on was collected in the summer, so there's green grass in the background and the lighting's all great, and then now you're still running that same model in the winter and the lighting is much darker, or there's snow on the ground, that looks a lot different to your computer vision model. So you'd want to take that new data, probably label it, and then retrain a model with those different variations that weren't in there originally. A quick example of concept drift might be the housing market. So, before, like if you trained a model 5 years ago, let's say you were using computer vision and you were saying, cool, take a picture of this house and give you an estimate of what this house would cost in this area. Well, if you trained that model even 6 years ago, 5 years ago, etc., the housing data has changed a lot since then. So if you had a price from 5 years ago, chances are it went much higher right now, at least in the US. So your mapping of your model really no longer matches to the mapping of the real world. So you'd want to update, again, retrain this model with now the correct prices of houses. I already kind of mentioned the bias and segmentation, which is really cool. Model explainability is really fun, where you can kind of feed in an image in this case for computer vision and gain some understanding of like the pixels that made the decision of why it made that prediction. Again, we're not going into this today, but if you do want to see more of this stuff, one, let me know if any of these sound super interesting. And then two, I actually do workshops pretty regularly, often almost every week. You can check out which ones are upcoming at whylabs.ai/events. I just shared the link in the chat as well. And I do cover segmentation and bias and explainability in some of those workshops. So check it out there. And then, all right, so that's enough slides. We've kind of understand maybe a little bit of intuition of why we want ML monitoring, some of the things that can go wrong with models in production. So let's go ahead and get to what I think is the more fun part is the Colab notebook, and hopefully a lot of people will follow along. So I'm going to share the link in the chat again. Again, all the links should be in the description below as well if you're watching on YouTube. So go ahead and open up this Colab notebook. And if you haven't already, you can create the free WhyLabs account. Again, there's no card or anything required. It should be very easy to sign up. We're just going to be using this to log our AI telemetry to the platform and then see how we can visualize it and set up a monitor so we can get alerts or trigger a workflow, kind of like I talked about, what you will probably have in your MLOps pipeline. And then also, I'll share one more link. We like to give away swag when we can. Unfortunately, we can't give it away usually to everyone who fills out the survey, but I will share the link to the survey here. I think it just really says, your name, etc., email, and then we can try to contact you to send you some swag. We usually pick a few people who fill it out every workshop to get selected. And we have cooler shirts now, so you can't see all my shirt, but it says no more ML oops, which is obviously a play on the words of ML ops. But when something goes bad. So fill that out if you want to get some swag. Open up that Colab link. And again, if you're just joining on YouTube, these should be in the description below as well. And you should get a link that looks something like this, or a page that looks like this. I'm going to zoom in. Hopefully that is good for everybody to see. Once you're here, go ahead and go to File and save a copy in Drive. This will give you your very own copy of this notebook. You don't have to worry about messing it up. You can always come back to this original link, save another copy from here. So I really encourage people to play around with code as we go, or maybe you want to write notes in it. This will give you your very own copy, and then you'll be able to run all these code cells from your Google account. So if somebody in the chat wants to let me know that they were able to open up the notebook, that's great. Hopefully we have no issues. I've used it before, so it should be fine, but sometimes something goes wrong with it being public. And then if you made a copy of it, going to File, save a copy in Drive, someone in the chat, let me know that it works for you. Someone said open and copied. Awesome, thank you. I would just like to make sure that I know it at least works for somebody, just so I don't go too far, then everyone's stuck and I have to go back. So awesome, thank you. Several people have said yes, it works. Thank you so much for letting me know. If you've never used Google Colab, it's essentially Google's way of hosting a Jupyter notebook, which if you haven't used a Jupyter notebook before, it's a really popular tool in data science and machine learning, where you can write code, see visualizations and outputs, and write text kind of all in one place. Google is awesome, and they give you some free GPU runtime as well. So if you want, you don't have to follow along with this part right here, but you could go look at change runtime type and actually see that we're going to be using a little bit of a GPU today. If you copied from my notebook, it should already be selected, I believe, on this GPU. And that's because we're doing a little bit of deep learning. Again, we won't be training a model for too long or anything today, but you'll be able to train a model with a GPU. And just keep this in mind, if you're getting started in deep learning or computer vision and you don't have a good GPU at home, Google Colab's a really cool way to get started. Again, the link is here. If you haven't created that WhyLabs account, you can. Link to GitHub for the WhyLabs library that we're going to be using today is also in here. And then again, there's a Slack channel in here. Ask questions in there after the workshop. If you ask them in there right now, I probably won't see them. So definitely keep asking questions in the chat on YouTube or LinkedIn right now. All right, so code cells. If you've never run Google Colab before, this is a code cell here. We're just going to run this code cell. And it's going to say hello world with Python. And you can click this little play button off to the side. Another way of running it is when a cell is highlighted, you can hit Shift Enter. So if you don't see me clicking this play button, it's because I'm hitting Shift Enter when a cell is highlighted, and then it moves to the next one. So now you can see if you ran that first code cell, it might have taken a couple seconds to kind of initialize a environment for us, because it actually gives us a whole little Ubuntu environment that we could interact with. So let's go ahead and start running these code cells. I'm going to scroll down here in the setup section, and we can run pip install WhyLabs. And I think we can ignore this restart runtime right now. There used to be some dependency, not really an issue, but basically with Colab, I didn't mention this before, it gives you a whole environment with some pre-installed libraries. So like we actually don't have to install TensorFlow today because it's already kind of included in here. And sometimes when you do that, if you install another library with pip, just like we did here, you might need to update a package that's pre-installed, and then you just have to restart the runtime if it was conflicting with the old one. But in this case, I think we're okay today. So I think we can ignore that, and we should be good to go. Oh, and I think we updated WhyLabs where you don't need to pass in the extra WhyLabs dependency, so that's why it's giving that little warning here. But I think we should be good. It's still installed. So let's keep moving on. So just as a quick note, so data and ML monitoring with WhyLabs. WhyLabs is an open source library for logging data of any kinds. I've already linked to the GitHub. You can check out more information there. But with WhyLabs, you're able to generate summary statistics. So it doesn't really contain your raw data anymore. We'll actually see what this looks like for images in a second. But if you're creating a profile with WhyLabs for a tabular data set, you could think of getting the summary statistics like the max, the min, the mean that belongs in each feature. It's a little bit more fancy than that. We use something called Apache data sketches under the hood. But just with those summary statistics, they're enough to allow us to track for things like data drift and ML monitoring, which is interesting. So like you don't have to move your raw data out of your environment. So people will set this up in your Python environment. You create these summary statistics, and then you can just log those over time. With WhyLabs or with WhyLabs, which we'll be using today, you don't have to worry about moving your raw data around. So that could be a really big deal for some industries like fintech and healthcare. And I'll just mention again, so because they just contain your summary statistics, they're really lightweight as well. So they're super efficient. You can move them around very easily. This is a big deal too if you're working with like edge devices, which I've done a fair amount of before as well with computer vision. And if you're trying to move a lot of images off of an edge device on a cellular connection that might not be too great, it's kind of hard and can be very expensive. But if you're just moving these really lightweight profiles, it allows you to monitor in some sort of cloud environment. And then maybe you just want to pass out the images that look very different than your training distribution, for example. They're also customizable, so we'll be looking at some out-of-the-box metrics today, but you can add your own custom metrics as well. And then they're also mergeable, so you could take profiles from different parts of the, like a distributed pipeline or from different dates, merge them together, and not lose any of your fidelity there. And it really just looks like this. You pass in a data frame to y.log once it's imported, and that'll basically create the WhyLabs profile. So let's continue down this, and we'll take a look at how to do this for images. So we're going to go ahead and import TensorFlow. We're going to import Keras from TensorFlow, and a couple other things here, including WhyLabs and this log image function and the WhyLabs writer function. All right, so this is just one little piece of setup here. Once we get through this, we'll be able to run through all the code in the notebook, hopefully incredibly smoothly, and see how everything's working in the platform. So what we're going to do is basically we've imported WhyLabs. We're going to download a data set here in a minute, and then we're going to start, we're going to log that training data set so we can compare any new data coming into our production to that training data set and see if it looks different in any way. And that's going to be a good indicator if our model isn't performing as well. So to do that, we just want to get a couple pieces from the WhyLabs platform. So if you haven't already, go ahead, create that WhyLabs account. I'm going to go into the WhyLabs platform. So it should look something like this to you, probably a little bit different. I have some data in here, so I'm getting, some alerts here, and I have 3 projects. You probably have 0, or there might be an example project in there. Also, just quickly note, there's this cool little summary tab. So when you do have multiple models running in here, you can kind of see how they're all performing over time, which is kind of neat. So if you're on a page like this, I guess I should get that link one more time to share in the chat if you haven't signed up already. I guess I should also ask, maybe in the chat, is somebody in the WhyLabs platform? Were you able to make an account and go in and get to a page that it looks a little different than this because you all have different projects, but we're able to create an account and get to this page. Somebody said, yes, works. Awesome. Thank you again. Thank you so much for letting me know. It's hard sometimes virtually to make sure that, everyone is getting where they need to be. So awesome. Thank you for letting me know. So what I'm going to do is hit this create resource button, and this will bring us to the model management tab. You can also always get to that same tab by going to settings, going to model and dataset management. But just starting out, just go ahead, hit this create resource button. It's going to pop up a interface that looks like this. We can see I'm over my free plan right now. You always get 2 free resources or models, whatever you want to call them, in here that we can monitor. So I'm going to hit edit models and dataset. I'm actually going to delete one of mine. So the test one I did a little bit before. And I'm going to create a new one. So I'll just call this CV workshop. You can call this whatever you want. Actually, let's give it a better name. I'll call this Jetson and Pi. So what we're going to be doing today is train our own computer vision model to look at the difference between 2 little computer boards, a Jetson Nano and a Raspberry Pi. And then this is important. Go ahead and select classification model as the resource type. This is going to allow us to pass in some data and automatically get classification metrics on performance. If you do leave this blank for now, you can always come back here and hit edit and then change the model type here. So I'm going to call this Jetson and Pi, and I'll hit add model or datasets. And now I have my new model here. And you can see it has this model ID attached to it. I'm going to go ahead and copy this. I'm going to go back to my notebook where we have these 3 things we want to get from WhyLabs. I'm going to paste in my model ID. Make sure that when you paste it in, doesn't include any new line characters or spaces. You want it to just be one string that looks like this. So model, and then your number. Yours will probably be like 1, 2, or 3. I've obviously created quite a few models in my WhyLabs account. And once you have that in there, let's go ahead and go to this access token tab. And let's create a new token. Oops, I need to delete some tokens because I have a whole bunch in here. You shouldn't have that error. All right, so I'll create a new one. I'll just call this CV workshop. Again, you could call this whatever you want for your API token. I'm going to create access token. It's going to bring up this token. I'm going to hit copy, and then I'll paste it into this API key placeholder string. And then we just want one thing that's on the same page. Go back to WhyLabs. You can see there's an org ID listed right here. It's also right here in this text. I'm going to go ahead and copy this over and paste it in. And now when I run this, this is going to set up environment variables where it's going to pull in this information when we need it. And we should be good to go for the rest of this notebook. I'm going to give everyone a minute and wait to see if there's any questions or you want me to cover this again. Maybe I'll go through it again very quickly. And yeah, I'll just mention, you might actually, if you're putting this in production, probably not, you're probably not using a notebook, and you'd probably want to save these as environment variables somewhere else in your system. So yeah, someone asked if I could repeat where to get the API. I'll go through very quickly again, the whole thing. So you'll have a page that looks like this. You want to go ahead and just create resources, probably the quickest and easiest way to get to this model and dataset management tab. Create a new model here, and then you want to get that model number pasted into that placeholder in the notebook. From here, you can go to this access token tab, type in a new token name here. It'll pop up over here. Just copy that long string over into the notebook. And then the org ID will also be listed here, as well as in another place in the text when the access token is generated. Somebody said they recommend to run the runtime since you have an error when you reach the second command. I'm not sure exactly what you're saying there. There might be, are you saying you want to you recommend restarting the runtime because it'll give us an error, or not running the runtime? I think if you just hit run all on the notebook, if you're familiar with Colab notebooks, if you haven't set up the strings here yet, if you went to runtime and hit run all, which is common, and then it'll run all the code cells in order, you would get an error because you didn't have these set up yet. Hopefully we won't get an error from any runtime things. I think we should be good to go, but we'll find out soon. Worst is we have to restart the runtime and just rerun some code cells. We'll be good to go. All right, so I'm going to keep going forward, but let me know if you have any questions in the chat. Again, you should be able to get to everything by going to this settings and then just go to the model dataset management and the access token, and you'll get everything you need to log the profiles we're going to generate over to WhyLabs and visualize and set monitors on them. All right, so this hopefully is just the hardest part here, just because now we can go run all the code in our code cells and hopefully everything should work. So I'm going to go ahead and keep going like I mentioned. Go ahead and run this code cell. This is going to download a data set from GitHub. It's just a small data set of images that I created, again, with Jetson Nano and Raspberry Pi. You'll see what they look like in a second, but they're just two small computers. We're going to build a classification model to classify what image belongs to what class. Oh, and I should mention, we've been running things like pip and the skit clone. To run terminal commands like this, you can just hit this exclamation mark at the beginning. It'll act like running a terminal command in your terminal. And if we list all the files in the directory, we can see now we have our data set downloaded. And inside there's something called days. There's a training data set and validation. And so we're going to use a training validation to train our model. And then we have this days folder. And inside there are multiple images. And that's how we're going to simulate in 7 folders. So we're going to simulate basically our model being in production and loop through those day folders as if it was a new day for each folder. And if you're new to Colab, you can explore these things actually in a visual interface by opening up this folder icon and expanding these out. All right, so let's create a dataset generator. We set some parameters in TensorFlow, so it's going to read these in from the directory that we just downloaded. We're going to say the image size is 180 by 180 and batch size is 10. You can go ahead and run this, and we're doing that for that training dataset and validation dataset. And here, this is just saying, when it reads in the images, they're going to be kind of compressed as 180 by 180 pixels. And then it's going to read in 10 at a time when we train our model. And it's going to keep looping through the data set and keep bringing in 10 at a time for however many kind of cycles through the data set that we tell it to run on. And we can see that it found 68 files belonging to 2 classes and then 10 files belonging to 2 classes as well. And then this next one, we'll see what some of the images look like. What we're doing is just importing matplotlib here. We're importing the images, and then we're just kind of labeling with the label and displaying the first 9 here. So we can see that this is the Jetson Nano. It's a very dark colored little computer with a GPU on it. And here's a Raspberry Pi. It's green. They look pretty different, right? And we just have different kind of variations of them. And we can see that class 0 means Jetson Nano in this case, and a class 1 means a Raspberry Pi. So we can list out in that training data set, here's Pi and here's Jetson. All right, so what we're doing here, go ahead and run this code cell, is we're going to go ahead and create something called a reference profile in WhyLabs. And when I talked about before data drift, one way to think about it is comparing new data coming into your model to the data that the model was trained on. So what we're doing here is looping through all the images in our training data set. We are merging them together with WhyLog, so they become just one profile here, and we'll look at what that looks like in a second. But this is going to give us kind of an aggregate statistics about all of our images, and then we're going to be able to compare those statistics of new images coming in against this training data set. So again, think of it, training data set, we have new data coming in. We want to see if that new data looks similar to our training data set or not. And if it doesn't, or it looks somewhat different, chances are our model may not be performing as well on it because it looks different than the data it saw when it was trained. So basically, people say like garbage in, garbage out of like training a model. If you don't have all the variations that you're going to see in the real world, chances are your model's not going to perform as well. So we'll go look at what this looks like in WhyLabs in a second, but we can also quickly look at what the profile looks like here because you can use WhyLogs to generate these profiles and then just use them in your own Python environment as well. So we can see, we'll see what all of the image statistics look like out of the box, but we have one here that's brightness. So that's just going to tell us like how bright are kind of the average images. And actually, I think it cuts off. So as average, we have the max. So basically, we'll just see like, oh, this is the minimum brightness. This is the average brightness between all of them. This is the max brightness in those images. And then it gets kind of truncated here. But we have a whole bunch of other statistics that we'll look at in a few minutes, because soon we're going to go ahead and write them over to WhyLabs, and we'll just look at them there. But basically, this doesn't contain any raw data. Doesn't contain any images, just statistics about your images. And you can also write your own custom ones too. So we have a whole bunch out of the box. You can read more at this link as well. But if you have any custom metrics that you want that don't exist here, you can go ahead and create your own. So let's go ahead and add data augmentation before we train our model. So data augmentation allows us to define some variations to add into our existing images. So let's look at one image here. All we're saying is we want to do maybe a random flip, and then also we want to do some slight rotation to our images. So every time an image gets read in now to TensorFlow when it's training, it'll slightly change it a little bit. And this allows us to get more out of our existing data, where our model is going to become a little bit more robust to some variations that we'll see. So for example, now that this is kind of changing directions, we don't have to make sure that we have all those variations in our data set. It's going to kind of create them on its own. And let's go ahead and apply this. So we're just going to say for our data set, add this augmentation to it. And then we have this kind of auto-tune feature in TensorFlow that's also going to allow us to kind of automatically make some adjustments depending on like the GPU and resources we have. And now we're ready to really build our model and then train it. So I think I'd mentioned at the beginning, we're going to use something called the ResNet 50 model. And it's easy to bring into TensorFlow because they have like a model library already built. I'm just going to create a function here. We're going to pass in the number of classes, the input shape. So that's the 180 by 180 that we defined earlier. And then we're going to pass in weights. So I mentioned transfer learning before, which means we're not starting from 0 here. We're going to use these pre-trained model that saw a whole bunch of different data. So it kind of knows how to make up objects and stuff like that. And we're going to pass it our new data set. And it's just going to kind of learn what we're looking for in our new data set. And you will actually see just in a few cycles of that small amount of images we have, it's going to be able to kind of learn to differentiate between a Raspberry Pi and a Jetson Nano very quickly, which is awesome. And we can do that because of transfer learning. So here we initialize our pre-trained model, which again is that ResNet 50 built into Keras. They have a whole bunch of other ones, so if you want to use different ones. We're saying include top false, and that's because originally, I forget how many classes is in ResNet 50, but it's something like 50 or 100 different classes it can predict. We're basically just chopping off that last prediction layer, and we're going to add in our own prediction layer for the 2 classes that we want to be predicting. So we're just saying false, and then we're going to go ahead and add in that last layer here. So we're saying if the number of classes is equal to 2, which in our case it is, we're going to use a specific activation function that's good for binary classification. Otherwise, if you're doing more than 2 classes like we are today, you might want to use something like the softmax activation. And again, don't worry if this is a little bit over your head if you haven't done a lot of deep learning or anything before. You can just run this code cell and then see we have our function. we're going to go ahead and run this and initialize our ResNet 50 model here. And we're passing that 180 by 180 with a dimensionality of 3. That means 3 colors, so like RGB in our images, because we're using colored images today. And then we're passing in the number of classes is 2. So it's going to use that correct activation layer at the end, so we can predict those 2 classes. And if we run this next code cell, this should give us a little output of the architecture. And I won't be going through all this, but it lists out kind of the whole neural network architecture for the ResNet 50. Should just take a few seconds. And for example, like this is the last layer that we kind of chop off and then add our own prediction layer here. But you can scroll up if you want to look at more of what's going on in here. Again, don't worry if it seems really complicated. You'll be able to run all this code and be able to train your model in this next code cell. So you can go ahead and run this. We're saying we want to run this for 3 epochs. An epoch means a full cycle of your data. So we had the batch size as 10. It's going to read in 10 images at a time, but basically go through the whole data set each time, or 3 times in this case. We have something called learning rate that kind of adjusts how your model learns about your images. And again, we won't go too deep into this workshop, but you can try playing around with these if you wanted. And I'll just quickly note that in real world cases, you're probably going to have way more than 68 images like we have today. And you'll probably want to train your model more than 3 epochs. You might want to, it really depends on the type of data you have and how much data you have. But, this could be like hundreds, for example, versus 3 like we're going to do today. And then we're just going to save a checkpoint for each time it goes through all of our data. We're going to basically save our model. We pass in some optimizers for training here. And then here, this .fit is actually calling the training. And so we pass in that training data set for the amount of epochs, and then pass in the validation data set. So usually when you train a deep learning model, you have your training data, which the model's learning from. You have a validation data set, which is kind of a holdout data set. Your model's not actually seeing that data, but you can run your model on that data. And it's not learning anything from it. It's just giving you a score. So this validation data set wasn't actually used to train the model, but you can see how well your model did on that validation data set, and it gives you a good indicator of, is your model going to generalize more on these similar images that didn't exist in your data set. So we can see in this case, we just did 3 epochs. Our accuracy went from the first training to 76 to 91 to 100% accurate on the training data set, and for the validation one is 80% here. So let's go ahead and just now we're going to load that model back in. ResNet model, or ResNet 50 model 2 is what I'm calling this. And that's just loading in that checkpoint that was saved after we trained our model. Now we can use this to make predictions. So if you run this, what we're doing is reading in an image that is never seen before. This is in the validation data set. And then we're displaying it down here and returning a score. So this says this image is, 25% sure maybe that it could be a Jetson, but the majority of it, it's, almost 75% sure this is a Raspberry Pi. So it would predict Raspberry Pi in this case. Someone kept saying they made it in the chat like a whole bunch of times. I don't know if I missed any other questions. Looks like they might have stopped spamming it, or they accidentally sent it a whole bunch. All right, so now we let's do this again on a Jetson Nano image. We can see for this one, it's very confident that it's a Jetson Nano, and in this case, very confident it's not a Raspberry Pi. So now there's a lot going on in this. I'll just run this, and it's going to take a minute for it to run through everything, and then I'll walk through. So what we're doing basically is looping through all of those folders that I said that are going to simulate kind of being days in production. So we have 7 folders, 1, 2 through 7. We're reading them in through the directory. We're initializing our WhyLabs writer. And then here we're going through for each of those days, printing out, working on this day, etc. And then we're reading in the file path. We're profiling it like we did on the reference profile, but we're just passing in the image here that we read in. We're updating the timestamp. So by default, it's really only a few lines of code to profile with WhyLogs and then send to WhyLabs. It's really just this right here. But because we're kind of looping through and simulating being in production. It looks like a lot more code going on here. And we're also updating the timestamp. So by default, when you write something to WhyLabs, it's going to be that date and time that you write it. But in this case, we want to backlog data. So we're updating the time or the date based on the date time but on each folder. And we're making the prediction. And then we're logging these predictions to a dictionary so that we can use these later. So right now we're just writing up to WhyLabs the input data, which in this case is images. And then we're going to keep the score or all those predictions so we can write those up later as well. You could do this in the same step, but we're just kind of breaking it out for the workshop just to make it a little bit more simpler per code cell. And so if you scroll down here, we can see that for each image that was in those folders, we're getting a prediction return. So, very confident it's a Raspberry Pi here. And this one, it was confident it was a Jetson. And then it says which kind of batch it's working with and gives you a prediction here. So this is cool. Let's go over finally to the WhyLabs platform where we can visualize all this data that we just generated. So I'm going to go back to WhyLabs. I'll just hit this icon up here, which will bring us home. And I have this Jetson and Raspberry Pi project now that I can click. You can click in here. This gives you a little summary tab. This gets more interesting as you add like monitors and more data, etc. You can go to the profile tab. We can see that we have profiles uploaded basically for each of those days that we mentioned. You can add profiles to compare against each other and see what the distribution looks like. You can see that actually, this brightness distribution between these two looks very different. A spoiler alert, there might be something going on with our data and production. We have this convenient little insights tab too. And this is really cool for a lot of unstructured data, especially like large language model. But we can actually see it's kind of telling us some potential imbalances or errors in our data that we might want to go look at. But what we're going to focus on right now is going to this input tab. And then you can click on one of these. We're going to look at this mean brightness for our images. It's going to be the main thing we look at this workshop, but you can see that we have these other statistics for images out of the box. Again, you can add your own custom ones to whatever you think might be relevant to the model that you're running. So this is what the brightness looks like for all of our images on those 7 days, right? So this also gives us kind of the upper and lower bounds, and then the median, which is like this dark line in the middle. So if I look at this first day, we can see that, the median, let's just look at the median in this case. You see the median is 189. The second day, it's 204, pretty close together. This day dropped down a lot, almost just 100. This one goes back to like 180. This one goes to 73, 100, and then all the way down to 5. So this tells me that our data just on the mean brightness looks a lot different on most of these days. Like there's 3 of these days that are in the higher range, and then a lot of them are in the lower range. And if we were to look at the profile of our training data set, which is what we basically want to compare this to, we'd see that it's also in this kind of range here of like 180, 190, etc. And these days where it's way less means that chances are our model's probably not going to be performing as well in that data. So let's look at, we'll look at the actual performance in a second, but let's look at setting up a monitor here. And this is going to allow us to compare this data that we have just in this visual right now. We can compare this data to our training data set, and when it does look very different from our training data set, to automatically send an alert to us so we can go look at it, or trigger a workflow in our MLOps pipeline. So I'm going to hit up Setup Monitors. This brings us to this tab here. I'm going to use this kind of predefined one, but you can create a new custom one here. You can even get really into it and edit all the JSON for all these monitors here if you want to do something entirely custom and awesome. But we have presets that make it really easy to get started as well. So I'm going to use this detect data drift for inputs for non-discrete values. So I'm going to hit configure. And now we have some configuration options. We're already detecting drift here. We have some options of doing entire data sets or segments. We don't have any segments in our data today. So we're just going to look at the entire data set. And by default, it's going to use the Hellinger distance here. which there's different types of metrics you can use to calculate data drift. Hellinger distance is a pretty common one that works typically pretty well for discrete and non-discrete values. I'm going to adjust this up. So by default, it's 7. It can take a little bit to tune your monitors depending on how sensitive you want them to be and how much variation you expect. I'm going to go ahead and change this to 9. This means that it's less sensitive. So it's going to really take a big shift in data for it to trigger an alert for us. And down here, we have some options of, what are we comparing this drift to? We're going to use the reference profile, but it is cool if you don't have training data sets. So some people actually use this just in their data pipeline and not really even the ML features. What you can do is set up something like this called a rolling window, where you're basically looking at the last 7 days or 90 days, etc., and seeing if any big shifts happen in between those days. In this case, though, we're going to look at new data coming in, compare it to that training profile that we created early on in the notebook. And then here you can set up alerts. I just have email right now. That's totally fine. But you can go and actually go to the global notification tab in settings and create basically different triggers that can happen here. So that could be email, that could be sending a Slack message, that could be triggering something with PagerDuty and actually having an automated workflow. Like a real project that you might want to do is have a workflow that gets triggered and then have data annotators go and annotate the data that you think drifted and then get the ground truth from it. And you can use that newly annotated data to retrain your model, hopefully. So go ahead and hit save here. Let's go back to the input tab. Let's go back to that brightness one. And now we can hit a preview on our monitor. So by default, it's going to run every 24 hours. But you could adjust that to be like something like every hour if you wanted. Oops. Oh, for some reason. So we can see, I don't know why it's not showing up here. There should be a little icon that pops up. It might be working on your thing. We can see that there's 4 alerts triggered here. And why is that not showing up? Let me refresh real quick. Well, I will ping engineering a little bit after this, but we can see that hovering over this. So you should be getting a little icon on the ones that are above 9. So if I hover over this, it might be hard for you to see unless I zoom in. If you're following along, you should be able to see this fine. But on this first day, I can see that the drift here was 8. So it was different than our training data set, but not enough to throw an error in this case or throw an alert. Same with this day. This day is a giant drift of 1, so it means it looks completely different. And we'll go look at in a second why these data sets are so different. This other day, we can see below 9 as well. This big dip one is also a 1. This is also a 1, and this is a 1. So let's go back to these slides real quick and see what's going on with all these different days of data. So this is what our training data set looks like. We saw some of this when we were loading it in. This is what the first day looks like. Again, remember, an alert wasn't triggered for this day, and alert wasn't triggered for this day. They look very similar to the training data set, right? Like there might be some other variations in here. Did say there was, some differences, and that's probably because our data set was very small. We didn't have all these variations around, and the lighting might be slightly different, etc. There could be more shadows in them, but very similar to each other, right? And then this day is day 3, the first one that had the alert triggered. And this looks very different, right? So what happened here? One thing could be that, there could have been a software update for your camera, and now all of a sudden it's zoomed in. That's, again, a real world use case I've seen as well. So someone might update a software package, and if you didn't do a proper test for it or something like that, it could be now reading in images very differently. Day 4. This one didn't have an alert get triggered, and because it's pretty similar, even though it did have some drift values, and we can see there's a difference in coloring. So instead of being that bright white background, it's now kind of this little bit of a tan background. So there's some difference, but again, very similar to what we saw before. And then day 5 and 6 and 7 all had alerts triggered, and we can tell why is the background color changed. And this is also real world use case I've seen in manufacturing plants before. Again, so you might train your computer vision model on all this data. you were using a white background or matte before, all of a sudden you change to a dark one without telling anyone using the model, and your performance is probably going to go down the drain, especially for a classification like this. And then again, this one also has the black matte. It's a little bit brighter. And then this one is awful. It's really dark. So again, I've seen this happen before. I think I mentioned someone turns off a light or something in a factory floor, and then your data is just kind of unusable here. So we can see that basically all these ones with big variations, we were able to detect that, over a certain threshold, the image is drifted. And then with that, either get an alert by email, Slack, or trigger something in the pipeline using PagerDuty. So we're going to keep going. There's a little bit more in the notebook, but what do people think so far? Is it interesting? Does it seem useful to something that you've seen before or that you've used before, or for a current model in production? I know I've run into basically all of these issues, like I mentioned before. That's kind of why I actually made these specific examples for the workshop, because they're all things I've experienced in the field. Brandon said, great presentation, useful for sure. Someone said, very interesting. Yeah, so yeah, has anyone set up any like monitoring or MLOps pipeline before? And sometimes, like, depending on your application, it might be okay for you to spot check. Like, that's what I did before as well. But if you have applications that, actually ties to like really high ROI, potentially money for your business, and if you don't catch these changes very quickly, potentially, again, not every application, could cost a lot of money, or potentially, hopefully you do have a monitoring system if you're doing something like outcomes for people in healthcare or self-driving cars or something like that. But basically, the monitoring and observability allows you to catch these issues if they happen really fast. And hopefully your customers aren't catching them later or leaving your product or something like that, or some sort of stakeholder is involved and then they lose faith in the model. Like, that could be internal in a company, could be external out of a company. Yeah, so hopefully this allows you to catch changes very quickly. Like I said, you could use this to trigger a workflow where you have data annotation, or data annotators come in, label these new variations of your images, and then you could retrain a model, and then you can actually deploy that new model, and maybe you shadow deploy it and kind of see which one's actually performing better. And we'll see how to log performance here just in the next part of the workshop if you stick around too. Someone said, can I use it for text data? Yes, you can. So we have a open source library called Langkit. I'll share this in the chat. Very similar to like what we saw with WhyLabs here in images, but we're extracting text metrics out of it. And I do have some blog posts on that as well. And again, if you want to come to a workshop in a couple weeks, or next week, actually, I think I'm doing an LLM one, you can come to there, or check out resources on our blog. We go into using this for text metrics as well. Do you have a specific text use case? Is it probably with a large language model, I'm guessing? That's kind of what everyone is doing right now. Someone said they got to drop. Yeah, no worries. Also, the recording will be available at the same link. So if you do have to drop and you want to come back for this last part, you can come back to the same URL and come back. So we saw how to monitor for data drift here, the input data coming into the model. We'll quickly see, I'll run through pretty quick for the last part after I answer any other questions, how to log the output from models. And then we're going to also log the ground truth so we can actually see the performance and see how you could do that with like two models, kind of like I mentioned. Someone said, it's pretty awesome. Very cool. All right, so I'm going to keep going through the rest of the notebook. I shouldn't take too long here, and I'll try to go through pretty fast because I know we are a little bit over time. All right, so now that we've logged all of our data up, the input data here, let's also go ahead and log the output from our model. And typically, you might actually want to be doing these in the same step. Like I mentioned, I kind of broke them apart for the workshop to make it a little bit easier to break down. But right now, after running the above code cells, we have this data frame that was also generated. And this data frame contains the file name for the image. And then it has the predicted class output. So remember, I think it was it 0 is Jetson and 1 is Pi? Or was it the other way? We'll find out in a second because I'll have the ground truth logged. but we can get the predicted result here, and then which day it was predicted on, and the confidence score from the model. So let's go ahead and log these up to WhyLabs or WhyLabs as well. And we do this same way we did basically for logging the data before, except for, we don't have to read in the whole image right now. We have just this data frame. So we're passing in that data frame to WhyLogs, and we're calling a specific name here in the data frame tab. So it says class prediction output, class score output. If you have the word output or outputs in a data frame or a feature, it's automatically going to log it in a outputs tab in WhyLabs. So go ahead and click this tab, and we can see that our data is in here. We have our prediction output and our score. So go ahead and click on this, and we can see, so I know why it looks a little weird. So right now it's on this quantiles view. Switch this to frequent items, and that's because we had the class of 0 and 1 here. So I actually wasn't sure if it was, a non-discrete value or labels. So if we actually had text labels, it would automatically put as a frequent item here. But we can see here, for every day, this is what we're getting returned on our predicted classes. So this is fairly evenly distributed. This day it's predicting all zeros, fairly evenly distributed, all zeros, mostly zeros, all zeros. So this could tell us something right away if we know a little bit about our data and what it might look like in production. Like maybe we should be expecting a pretty evenly distribution. Like let's say we're always manufacturing the same number of Raspberry Pis and Jets and Nanos every day, or about the same. So it should be somewhat of an even distribution. Well, if I look at this, we can see that, it's predicting one class on 3 different days, or actually 4 different days. And we kind of already know that there's 4 days where the data looks a little bit different. So we're guessing, just looking at the predicted output too, that if we know the distribution that we're expecting, we could see something's probably wrong with our model here, because we know we should be expecting a fairly evenly distributed number of Raspberry Pis and Jets and Nanos. We could also look at our predicted score. So how confident is our model over time? These first 2 days, it was pretty confident. Then after that, it definitely is kind of all over the place here. And then it goes back up on this last day. So this also tells us, we know now that our data drifted because we saw it just from this input tab on those statistics. And then over here, we could see, well, our model definitely got less confident on those days where it looked like data drifted as well. So now we go back to the notebook, and let's go ahead and add ground truth to our data frame. So here I'm just saying, if the file name contains a jet in it, it's a Jets and Nano, so that's class 0. And then the other one's going to be a 1. And I think I messed up somewhere, but this should be totally be fine. I accidentally added another ground truth that's just none in here. Just ignore that. We actually won't upload that piece of data, so it's fine. And then here, we're going to write this to WhyLabs again using the WhyLabs writer. Again, looping through for the 7 days. And we're going to now call something from WhyLogs called log classification metrics. So it knows is going to be classification metrics. We're going to log that ground truth and the predicted output up, and then we're going to get those metrics that you might be familiar with, like accuracy and F1, et cetera, et cetera. So let's go ahead and log that. And they're logging up. And then I'll go back in the WhyLabs platform here in a second, but that's going to be the last part of the code in the actual notebook today. So if you want, there is a form that you can fill out to get a certificate for attending. And then there's also a whole bunch of resources here to keep learning. So one, going more about Keras and TensorFlow. Again, you can sign up for WhyLabs if you didn't already and you saw this and it looked really cool and now you want to try it out. Go ahead and create that free account. There's a great article on detecting and fixing data drift for computer vision. Go learn more about WhyLogs. Go to the Slack channel, and I'll share this link in the chat, actually. So I would love to, if you have any questions later, I'll be in the Slack channel, and that's going to be a good place to ask them. Also, if you want to stay connected with me on LinkedIn, that's going to be a good place to ask as well. I'm fairly active on there. So I'll paste that as well if you want to stay connected. Right, so now we've updated our ground truth values. So this would be if, somebody actually came and manually annotated these. Is kind of what we're simulating here. So most of the time, right, you're running a model in production. You have the data going into your model. You might have the outputs of your model, but you don't know what the actual class was typically until you have someone go in and verify it. So in this case, we saw data drift happen in these 5 days or 7 days. Maybe we kicked off an annotation job, or we got notified. So we told our data annotators, or we manually went in and said, yes, this is a Raspberry Pi. This is a Jetson Nano. Now we can compare how our model actually did on the predictions. So we can go to this performance tab, and this will bring up, all these different metrics like we talked about. And let's just look at accuracy for now. I know it's not always the best metric to monitor or indicate performance of models, but we can see in these first 2 days, very accurate, 100%. This day, 50%. So I don't know if it's just guessing and it's 50% right, etc. Again, back to 100, 50, 75, and 50. And this correlates with, in our input data, all those days where there's that dip in brightness. So it's kind of like we saw a lot of the workflow of, like, if we just saw data drift, we think something might be up. We could then go and inspect those outputs. If we know our data well enough, we could definitely kind of say, yeah, something definitely seems to be up here. Then we could actually get the real ground truth and see how badly our model was performing, because we kind of suspected it was. And we could see that it was not performing great. And then this is where you could also now use this annotated data, because now we have these classes defined for that new data that it wasn't performing well on. We could potentially, if this data was good quality, we saw that some of it might not be good quality. So like, this is fine. We just had a change happen in our environment. So now it has this dark matte in the background. These ones, maybe that's not good quality, and we don't want to train our models on these at all. And that's just a different issue that we have to fix in the factory. But we could train with these new ones where the images are actually fine. They're just a different variation. And now that we have the annotated data that we looked at the performance with here, we could just retrain our model, deploy it. And like I mentioned, in this case, our model wasn't doing so good. So maybe we want to go ahead and deploy this new model. We think it's going to do way better. But you could also shadow deploy this and then log the metrics here as well, and then compare these two models over time. So maybe you want to put it back out in production for a week and then select the model that was performing the best over a week versus just putting one out blindly. And like I mentioned, that's kind of all we have for the workshop content here. I'm going to stick around just for a couple minutes to answer any questions that people have, but I do have to run for another meeting here in a little bit. So one, let me know. I think people already said this seemed really interesting. They have some questions like, can they use it for text data? The answer is yes. You can use it for tabular data, image data, text data, any data you can think of that you can extract interesting statistics from. You can log it here in with WhyLabs and WhyLabs, and then set up these monitors on it so that you don't have to manually look at those visualizations every time. You can get notified when something happens and hopefully, mitigate any risk very quickly. So again, I know there's still quite a few people here, so feel free to let me know any questions you have in the chat. And if you thought this was interesting, does it seem like something you would want to go use? Have you thought about implementing something like this in your pipeline before? Would definitely love to hear it in the chat for the next few minutes. I know there's also a little bit of a delay sometimes from me talking to actually getting to you on the stream. So I'm going to wait around for a couple minutes. I think people already had some remarks and questions before, so I'm not sure if there's going to be any more. Again, also you can join the Slack channel. Link is in the description. Follow me on LinkedIn or connect with me on LinkedIn, and feel free to ask me questions there as well. Someone said, great content. See you in upcoming sessions. Awesome. Yeah, I can't wait to see you there. Hopefully I will see you at more sessions. I do one almost every week sometimes. Sometimes I'll take a week off of doing a workshop. Someone asked, could I explain a little bit more about the shadow deployment and selecting the optimal model to deploy based on the results? You briefly touched on it. Thanks. Yeah, so I think in this account, I probably don't have a model to show right now. But basically, like I'd mentioned, there's actually before I go too deep here, I can also link to a recording from a previous workshop where we actually kind of talked about this and went through a whole process of setting up an MLOps pipeline. So give me a second and I will pull that up for you. And then actually we talk way more about it. But I will briefly talk about it as well. But let me just make sure I share that with you here so you can go watch it later. All right, I'll put this in the chat. So this is a link to another workshop I did a while ago with a company called Toloka, which is a crowdsourced data annotation platform. And so what you can do is, like we saw data drift happen in our platform. So drift occurred, an alert happened here, and we're saying, hey, we think this data looks very different. We should probably go look at what's going on. Maybe we go also look at our outputs tab, or we can also set up monitors. I didn't mention this, I think, but we can also set up monitors on our output tab. So instead of also manually looking here, we could have some sort of monitor saying like, if the frequency of these items now changed quite a bit, also trigger an alert here. But let's say we're just looking at the input drift and have an alert based on that. We could kick off a crowdsourced data annotation job, or now that we know about it, we might go in and label the new data. And then with that, we get this ground truth performance metrics. And then from here, what we could do is retrain our model with that new data, put it out in production. And then what you can do here is if you have two models, actually, so here's an example of another model I have. And what you could do is basically, if I put a new model out in production, I can do something called shadow deployment, where we can have two models here. One is making, or both of them are making predictions. One of them is actually only going to the stakeholders. So like if you're making a prediction about, serving new items to customers on an online store, you could be using that old model still to see to serve the recommendations, but you could have another model that's making predictions, and then you're logging them here to kind of see how well it's doing. So, and then you can compare these over time. And if your new model is better, then you could deploy this out there. I don't know if that was a good example, but basically you have two models, both making predictions. You're logging both of those predictions, but maybe only one is actually giving the results to a stakeholder or a customer in this case. But even though you have two models, and then you could just see over time, like, okay, I can compare the results of these two models. And I actually think that one that I have in shadow deployment mode, where it's making predictions but not actually interacting with the users yet, it is actually performing better. Now I want to go ahead and deploy this one that's better. Someone said, is this only for models in production, or can I use it to research in research to monitor my model? You can definitely use this if you think it's going to be useful for research or for evaluation. A lot of our customers use this for models in production. I think there's a lot of value that comes from that, especially when it comes to like segmenting and stuff like that. But you can definitely use this in kind of research practices. So for one example, like if you want to backlog data just like we did, and add in different variations for each of those days, that's a good way of seeing how your model's performing on different variations. Another way, I think you were the same person who asked about logging text metrics. So I think actually I'm seeing more people use us in some of the evaluation phase or research phase for large language models. And again, I won't be able to go too deep in this because I have to run in a few minutes. But if you go look at some of the Langkit resources, let me pull up our blog real quick. There's some really cool stuff you can do for large language models. So here's one using LangChain. Here's one using Hugging Face. I'll share these in the chat if you want to check them out. Let's go look at this LangChain one though real quick. So just real quickly, this is kind of how the Langkit works, and then you can log these metrics to WhyLabs. So you get things like these extracted metrics from Langkit, which is like things like sentiment score, jailbreak similarity, toxicity, etc. And then you can log these metrics over time in WhyLabs, just like we saw with the image data, but it's now these language metric data. And something really cool about this is if you're doing like fine tuning on LLMs or really any model, you could use this, right? Like you could fine tune a model, monitor the performance, just like we saw between each model that you have, and then compare them to each other. But one thing that I've seen a lot of people do too, because a lot of LMs, you use prompt engineering to get different results and improve your model. So instead of fine tuning, which can take a lot of time, depends on what you're doing, etc. But prompts are really easy and cheap to do. You just have to change some text, and then you could run the LLM with like 10 different prompts, right? And then maybe you have it in production or in a research project or something like that. And then you can monitor over the week which prompt performed the best out of whatever metric is that you want to have that defined best for. And then choose that prompt that worked the best and deploy that out or use that in your research, etc. So I think that might be a really cool thing for you to look at, especially if you're doing large language models, because I think you were asking about text data, right? Also, we have, I think I had already shared, but we have an event next week, right? Or is this the week after? I forget. This might be the week after. But you can check out this event, which is using kind of it covers a lot of stuff that's in the Hugging Face blog post. We'll go a little bit more, but it's going to be a live workshop like this. So you want to come in, ask questions there, go through, again, probably a few slides like we did today, but then most of it's going to be us running through a notebook. We'll also use Linkit to set up guardrails too. So with those extracted metrics like we saw, for example, jailbreak similarity, you could use that in your environment. Like we saw, we could get some of those metrics in our Python environment with WhyLabs, and then you could actually have like a guardrail saying, if the jailbreak similarity is above a certain amount, like don't pass this to our model or don't return a response. Awesome. I don't see any other questions right now. And like I said, I actually do have to run to another meeting. So this is great, though. Thank you so much for everyone attending. And I always extra thank you to everyone who asked questions or said hello in the chat and told me the audio is working, etc. Thank you so much for coming out. I'm going to go ahead and wrap up the stream. So again, if you do have any questions later, like if you're using this in your own project or putting something in production, join that Slack channel or connect with me on LinkedIn and ask me questions in either of those places. I definitely recommend the Slack channel as well, because there's other engineers in there and practitioners. So you won't just get my opinion, you'll get hopefully other people's opinion as well. But thank you again, everyone. I'm going to go ahead and end the stream, and I'll talk to hopefully some of you later. Have a good rest of your day and week.